All right, so I made a mistake going into this video. So this is where we left off, and I changed the name in the comment, but I did not save this under the new name. So I just overwrote my old code. So right now, before we make any further changes, I'm going to update this and save as, and you should do the same thing. Save as SEIR D model without a version 2. I guess we should have saved it as version 1, so this should be version 2 by now, but it is not. Okay. In this code, we will add I threshold equals 0.02. Remember, that's at 2% of the population. If we exceed that, the death rate will go up. And if we're below that, the death rate will stay at 1%. Okay, so add I threshold to determine if death rate is 1% or 5%. We could actually build that into the code as two different death rates because as more research comes in, those numbers could change, but for now I'm just going to make them 1% and 5%. Maybe that's something you could take on in your final paper, is making those numbers more variable and flexible. So let me continue here. Let's figure out what it is we need to do based on the logic in our last video, right? So first of all, I need to add I threshold. Let me do that right before T max. Okay, so this is the level of I that determines which death rate. As long as 2% or fewer or less of the population, I should say, are infected, we will have enough hospital capacity to treat 5% of that 2%. Okay, so we should be okay in that case. Whoops, it looks like I didn't put a semicolon somewhere, so I'm just going to fix that. I have a green box. Okay, so continuing downward. This does not change any of our categories, so we still need memory for all of the same vectors. All right, and then we get into the brains of the calculations. We still have our three time periods that determine how rapidly people are being exposed, so that doesn't change. Nothing actually changes until we get down to the calculations for DR and DD. Okay, so right now these calculations, these 4 bits of code, are true if we are below I threshold, right? So let's put in if I is less than or equal to ITH, then we want to do all of this. Else, and I'll put an end statement in. This will be the other category, and let me indent this properly. So you use Control I, and it indents properly. Okay, so the if is below threshold amount, means we have enough hospital beds, everyone gets the best treatment, right? Else, spaces in here, this means it's a 5% death rate for I over I threshold. Okay, so we're going to have 2 different death rates depending on whether you were one of the lucky ones who got into the hospital, has the potential, I should say, to get into the hospital, or if you're part of the population that exceeds I threshold, therefore you will have no options for going to the hospital should you need it. You won't necessarily need it, but if you do, it's not available. So that's where you probably want to look at what we had in the last video. It wouldn't be bad actually to have copied the logic flow onto a sheet of paper, but I'm going to code that in right now. Okay, so what we have is the following. dr will equal, we're going to put one line of code, we're going to add together the two rates, 99% times C times I threshold. Okay, so those are the, that's the portion of the population that did get the proper hospital treatment. Okay, so that would be, so for I threshold of them, they have a 99% likelihood to recover. But then only 95% are likely to recover if they're in the category C times, we saw if they're over the threshold amount. So the way you find out how much they're over is you take I minus I threshold, as we stated in the last video. Okay, so these people, the ones who are in the pool where they were, I guess, infected before you reach the threshold amount, they'll have a 99% recovery rate, but the overflow, that's what this is, will only have a 95% recovery rate, and so that's what we use here. Then we kind of have the, you could almost say the complement of that for determining the death rate. And that would be, so again, actually, let me just copy the same line of code. Okay, but we're going to reverse the numbers. So if 99% recovered, 1% of those would die. And when 95% are recovering, that's less than 5% of those, of the overflow population will die. Okay, so that's what we have to do there. All right, and then we still want to have our R's. I probably need to, it's just like what is above. The new R value, R of IT plus 1. Actually, I can just copy the code. There's no difference between what we have above. The rate of recovery is different. Oh, and there is an error here. I have D little r. The state variable is a capital R. It does matter which one I use, but I can use the same lines of code for just adding up the R's to get the total over time. It's exactly the same code as we had before. We just have different rates. In fact, you know what I'm going to do that's even more efficient? Since we have the same line of code twice, I am going to actually remove it right here. And I'm going to put it down here. And that means I can also remove it here. So the rate varies depending on which category we're in, but we can add it the same way in either case. So then I can remove this. So I can put it after the flow of the if statements. This will just be more efficient. So whether or not we're over I threshold simply determines the rate at which R is changing or the rate at which D is changing. But then we can add those rates times time onto the amount we already had in either case. So we only need to put those lines of code in there once. So that's just slightly more efficient. MATLAB won't really care. And the program will run just as fast either way. But if we can have less code, it's cleaner, it's nicer, right? So that should have take care of the problem. If we go over the threshold, we should get different rates of people dying. Okay, so let's go ahead and run the code again. And as I would expect, something is wrong. And it looks like I must have used a capital C there instead of lowercase c. So let me go to line 53. as I thought. It looks like they did the same thing in line 54. So let's just change all of that right now. If you put capital C's, change all 4 of those C's to lowercase c's. Now, that won't mess us up. Maybe something else will. Okay. So now, what does it not like here? Let me pause the video and figure out what is wrong. Okay, it took me a couple of minutes, so it may look like I figured that out in 3 seconds. It actually took about 4 minutes. I is an entire vector of values, all right? So that makes dr an entire vector of values, so thousands of independent values. And when I try to add dr times dt onto a single value and put that into something that should be a single value, it doesn't work. So what I messed up is algebraically, we're thinking about I minus I threshold, but it's a specific I value, the one for the loop which we're in right now. So I need to put in a specific I value, and that should fix the problem that we just had, and hopefully all of the problems. Let's see. Looks like it ran. We can pull up the figure. All right, and I suspect that our death rate probably went up a little bit because of crossing the threshold value of infections, or I think we did. Okay, so let's see if we did cross the threshold, and perhaps we want to add a line for the threshold infection rate. Okay, so let's see what happens if we go down to 0.03%. Did our infections go over that? They did. Okay, so we had in that second wave, we exceeded hospital capacity, assuming we haven't grown our hospital capacity yet. Okay, so you can actually see the death rate going way up before that. Now it looks like I have a problem. It looks like my death rate is actually coming down. So there must be something wrong with the code that would cause the death rate to come down. Let me go back up to 5% of the population. And it appears the death rate should be flattening, but it does look like, if I zoom in on this part of the graph, it does look like it's coming down. Maybe not, maybe that's an optical illusion. Let me just check to make sure that the values for D never come down. Okay, we do have a problem. Actually, let's look at what happens if I extend out to 80 weeks. And I run this. Let me see, I need space to run this. Whoops, give me just a moment, okay. Zoom controls are the way, yes, the number of people who have died is decreasing somewhere after 52 weeks, it's clear. So there is an error in my code. Let me find the error. Okay, I was suspicious all of the other curves except for D seem to be working. And I realized I made the same mistake that I had in the other places. When I write I mean the I of the time step we're in, the loop that we are in, okay? And so everything within here should be individual values of I. Right here in the if statement, I once again forgot to work with an individual value of I, and I worked with the entire I vector, and that created a problem. I'm not sure exactly what it did. I'm surprised it didn't crash the code. It's actually worse when your code runs but doesn't do the right thing, especially if you don't catch it. So that needed to be if I of IT, the specific I that we're on, if that is less than I threshold, then we follow case one, the low death rate, and if it's over I threshold, we have to compensate with a higher death rate. Okay, so now it works. You can see that the death rate, the proportion of people who have died only goes up, never comes down, but it does level off. So now we can set that back to 52 weeks. Look at 1 year. Let's see, so go to 52. In some cases, you may want to, when you're exploring this topic, you may want to extend out beyond a year to see what happens. If it looks like things haven't leveled off yet, then do look beyond a year. So here we are with code that is working, but a nice feature would, we put our threshold line at 2%. Why not just add a line to the code, a horizontal line in the graph right at I threshold, so we can see when we've crossed that line or not. Okay, so let me add that in. Okay, we're going to want that in both the graph for I, which is case 3, and then we'll add it into case 6, the last case. Okay, so what I need to do is, in addition to plotting all of the values, I want to plot a horizontal line that runs from 0 I threshold over to the T max I threshold. But the quirky thing in MATLAB is I have to put both X values in first. So I'm going to put in 0. I want X to start at 0 and end at T max. Okay, and then I will put in 2 Y values, and they're both I threshold. And since this is a hypothetical line, let's put a double dash R in, and that'll make a dashed line that is red, just like the infection line. And I need to put a comma before the line width. And so that should put in a line in the infection graph, or infected graph, I should say, right at the correct height. Okay, so let me reemphasize what we did. This 0 gets paired with this Y value. So the first X value gets paired with the first Y value to determine a point. And then the second X value gets paired with the second Y value to determine another point. And since those are the only 2 points, they get connected and form a line. MATLAB does this because we might want to connect 100 points in a curve. So we put all of the X's first and then all of the Y's second, and MATLAB goes down the 2 vectors and pairs them to make the graph. So that's why we don't use coordinates. We put in all of the X's and then all of the Y's in 2 separate vectors when we're pairing things. That's what happens in the T and the I. There are thousands of time values and thousands of I values that all get paired together. Okay, so let's run case plot choice 3 and see if this actually worked. And if so, we'll add it to plot choice 6. There we see it. We've gone over the threshold, and that's going to cause the death rate to go up. That's a real emergency. Okay, that's what we were afraid of. If you look back at around 10 weeks, that curve was definitely going to go over the threshold capacity, and we didn't have time to adjust. So right now, this would be bad news. Somewhere in the fall, we will go way over the capacity of our hospitals if we aren't careful. Okay, so it really comes down to what this A3 value is. We need to keep that low enough that we stay below that threshold capacity, so that we don't have a medical emergency where basically our medical system collapses. So that's what we're going to try to avoid in the fall. Now let's add that line to graph 6. So let's take what we had in plot 3, which was the dashed red line. And let's add that into plot 6. So I just copied that. I highlighted it and copied it. So right here, after I do the red line, I will paste and put in my dashed red line. Let's tab that over so it all lines up nicely. And now, whoops, I have a bunch of red now, or orange, let's say. A lot of things just went wrong. Oh, I know what I need. When I put that in, I needed the ellipses to say I'm going to the next line. And I need a comma right there, and everything went green. Okay, so you always have to end a line. If you're extending your code down to the next line, if it's a continuation on the next line, you have to have a comma and then the 3 ellipses, and a comma and the 3 ellipses, And that took me down to the next line. And hopefully this will work for plot choice 6 now. So let me go back and try plot choice 6, which will be everything all at once. And we can see that threshold capacity, we went way over it. And so you can actually see our deaths came up way over 1% because we have saturated the hospital. And you can see that the deaths really, really went up out there, past week 30, because that's when we had overrun the hospitals. Let's just real quickly see what happens if we start bringing that A3 down. Let's bring it down to 1.2. Let's see if the situation gets better. A lot better. You can see the fatalities. Let me go 1.4, which is where it was. Okay, if I bring that down to 1.2, the black line drops a lot. Okay, those are lives saved, right? We've still overrun our hospitals. One thing you might be able to do in your project is make that threshold line and actually make it an increasing line. We have plenty of time, about a half a year to prepare for this. Well, maybe not half a year, we're at about week 20 now. So we're probably looking at, a quarter of a year anyway. So we've done a lot in the couple of weeks that we've had. So in a quarter of a year, perhaps we can do a lot more and bring I threshold up so that we could handle that second wave of infections. Because if I threshold were a lot higher, we wouldn't, the death count would be a lot lower. Okay, so let's just pretend, let's double I threshold, or let's just actually bring it up to 3%. Okay, so if we expand our capacity for handling COVID by 50%, you can see the fatalities dropped way down. Okay. Oh, now I do have a problem with that threshold in there. It threw my legend off. Okay. I think I don't like that. The deaths should be black. So I think that I will take this threshold line and put it into a separate plot, okay? Because right now it throws the legend off. Or perhaps, you know what, I think I will get rid of it in this graph. I'll only leave it in plot 3 so that our legend will behave. Okay, so I'm going to take it out of plot 6 just because things don't line up for the legend. And because the legend only has those 5 things. Or I could put it in as I theoretical. Let's put it back in. You see me just running along with this, comma, dot, dot, dot. It is back in there. But that means in my legend, I need to add a line. Troubleshooting as we go. We'll put I theoretical in there, and let's see if that takes care of it. Okay, so let's run it again. That works perfectly. Okay, so I just needed to add I theoretical in the correct place in the legend, and then all of the colors line up again. So I have a nice line there to show me what hospitals can handle. And part of the strategy of governments now is to make sure that we don't go over that. So this would still be a little bit problematic, but it's possible we would have time to raise that threshold line so that we would be able to handle that next wave and keep our the number of deaths down significantly. Okay, so as long as we stay below the red line, the deaths can't go over 1%. All right, if we go over that line, the deaths can go over 1%. And since 1% of New Jersey's population is about 90,000 people, the case that we had a few moments ago with 1.4 as A3, move this over. So if we just take A3 from 1.2 up to 1.4, okay, so that's just a little extra. Maybe we get to go to the movies, but looks like, okay, not a full percentage, but that might have been 60,000 extra people died because we all got to go to the movies. So as the government officials are trying to weigh decisions of what to do and what not to do. Lives literally hang in the balance based on decisions they make. The problem is decisions they make now will affect us, 2 or 3 months later. So it's very hard to know how a decision today will play out in the future.